Okay, folks, and I think I forgot to push a button. Testing, testing. All right. I think. Okay. Hello. Okay, well, this is going to be exciting. I do apologies and welcome 10 minutes late to a version of the U.S. section of our last lecture. And I will stop because I was talking away and now just discovered that nobody was with me. Okay, so suppose we want to, so Prolog includes something called definite clause grammars. Definite clause grammars can be pretty slick. A definite clause grammar is nothing but a way of pretty much directly encoding. How many of you know Backus-Naur format? Prolog contains a way of including a certain class of grammars called definite clause grammars, and that allows us to build parsers pretty much just by writing out the syntax of the language. So I was going to write a little of making some English. So the way you get access to a definite clause grammar is to use the built-in predicate phrase and you give the definite clause grammar. Read the RFC for more. Yeah, if you read RFCs, boy, you get exposed to these things. So there's a phrase, and it's going to decide. These things work kind of in two modes. One way is that they can generate strings that are parts of the language, and the other is that they can generate. The other is that they can tell you whether a string is part of the language. Very Prolog-y, right? Okay, so let's decide what a sentence is. Whoop. A sentence is a noun phrase followed by a verb phrase, right? And we, of course, are only doing a small subset of English. So, all right, well, what's a noun phrase? Well, for us, for the moment, it's going to be a determiner followed by a noun. The cat, a boy. And kind of writing these out, right? A verb phrase, Bob saw the cat. So that's going to be a verb followed by a noun phrase. Or, Bob saw Sally chase the cat. Okay. So you could put a whole sentence in there. We have a recursive definition. And then honestly, it's hard to come up with good exercises for DCGs because they really are kind of a one-trick pony. They do this. So, okay, at this point, then, I want to define what a determiner is. The determiner is a or the. Now we have to ask, well, what do we expect X to look like? And to keep our lives simple, I'm going to make X a list of words. So, the cat scares the mouse. And then, so when I'm here, so put something in a list, it becomes a literal. I'll leave that on the end. It becomes, and now this literal thing must be encountered in the input to match. And then I've got some more literals. A noun could be, well, we're omit cats and mice, and we're only going to have scares and hates. By the way, I'm taking pretty solidly from an example by Michael Covington. So notice these don't have any arguments, right? So, but this, which is the DCG operator, is going to get expanded into a clause with two arguments internally. And those two arguments will be used as a list. Okay. So I'm going to compile that, and I call that I called it English. Is it true that that's an English sentence? Yes, it is. Let's find out if we can scare the scares. No, that's not English. Okay. And this is actually pure Prolog, so as long as we don't have an infinite list, we can enumerate. Not all DCGs will work both ways. You have to have basically a finite language for that to work. Okay. Where is everybody on the reading about DCGs? Let me know in the chat, please. I'm going to keep going here, but so that's the basics of it. Now, now we can end up with things get, okay, haven't read much about DCGs, I'm following. Okay, end of the tutorial. Great. All right, we could have so we could have a sentence that we could demand that there be number agreement. number agreement in natural languages is when the verb agrees with the form of the number of the noun. So, cats scare men, but the cat scares the man. Okay? And if we have a plural, so for plural, we don't need a determiner. So, okay, we're going to go back, and I'm going to tell you what. And if my trackpad would quit interfering with me. This is going to be number in the grammatical sense, and that's now long enough. I'm going to change it to this form. Okay, so now these two are going to have to agree, and I'm going to have to add an argument to noun phrase, and I'll have to add one to verb phrase. Moment. The determiner could itself have a number. You can say cats scare men, but you have to say a cat scares the man. So we have to make that agree, and we have to make that agree with the number for the noun. Okay? All right, and so just so people are clear following along, I'm going to singular and now we're going to add a plural one, which is nothing. If we have, and we're going to have to do the same thing here. And then cat is cats. The plural version of mice of mouse is mice. Okay. This is the singular version of verb. It's scare in plural, right? Cats scare men. This is the singular version of hates. The plural version is hate. Okay, and now we need to do the same thing for the verb phrase. And I'm going to be smart, and I'm going to use cut and paste. Oh, and now I guess I'm going to need to return the number from sentence, because our sentence is always, Sally saw, yes, it needs to agree. At least I'm actually just going to trust Michael. Okay. This making sense? You'd have to exclude from many. Yes, no question about it. This is in no way a complete grammar of English. Oh, can we have a plural that appends S? Oh, you were answering, Chandra. And yeah, you could. You could. So, and syntax highlighting and syntax coloring saves me once again. So, okay. Whoop. Something's not sentence 2. Yes, that's because I now need to call this. And I don't need it at the top. If I really didn't want to have that, I could call it with nothing and then have it call with a number. If I didn't like doing this, I could do this. Actually, just the typical Prolog pass with an argument you don't need. Okay? And a cat scares a cat. A cat scares a mouse. A cat scares the cat. And we're going to go through a whole bunch of singular ones. And if I just hold this down, a cat scares a cat scares a cat. And we're going to be the fact that we included we could have a whole sentence out there means that now we're all recursive reification. So, but now we can find out that cats scare men. Whoop. Wonder what happened here. Oh, I don't have men in here. Cats scare mice. That's true. Okay. All right. So let's go back and make Chandra's work. A noun, plural, and tell you what, we can make a plural noun be a singular noun followed by and I need this in single quotes. I guess I just need S. This is going to come. What is the operator point at? That's the DCG operator. And yeah, up top, you'll see the way you use a DCG is you call it with phrase. And the DCG, and then actually this thing is just implemented using term expansion. Encounters this in the input and says, oh, this thing's functor is this arrow, and just as if its functor is the neck, it's going to be a rule, but this thing's functor is the minus arrow, and so this must be a DCG, and so I'm going to treat it like a DCG. Here's Chandra's rule, and and I'm going to insist on my phrase, and just because I don't want to singular ones since they're first, I'm going to say phrase. Well, I can now, in fact, do English cat S scare, and now included mouses in our language. Oops. Cat S scare mouse. How did that break? By the way, I don't need those quotes. Let's step through it, because it's not obvious to me how that broke. And nope, and the debugger is not going to get bigger. So we're going to step into sentence, and then it's going to go into, all right, and then we're going to get a plural noun phrase. I asked, why did I get, and then I'm going to get, whoop, no plural noun. Okay, so noun phrase is failing. I am going to try this again. I don't know quite what happened. All right, so at this point we do not have number. We haven't committed to being plural yet. So the odd part is it's going to the third term. Oh, yes, it has to go to the third term because it's attempting to parse cat and then looking for a and then looking for a verb. So, all right. So, I have the funny feeling that, let's see, that ought to work. Is a noun. It's just a noun followed by an S. I'm not seeing why this is not working. English. Let's try. Okay, so it's not actually getting it somehow. Why would it not be doing that? It's getting cats and mice, but it's not getting the first one. I'm really baffled by this. This is very simple. Aha! It would have helped if I had compiled. By the way, demonstrated a little Prolog tip. If you are in the graphic debugger and the highlighting is messed up, it's because it's working from the compiled. Yeah, the syntax highlighting was messed up because I failed to compile before running my demo, and now it's working properly. So, okay, so, and now I'm just going to leap this thing, and it says true. So now it's happy. And hang on. Okay. Now that Annie's had her little crack. So, all right. This pretty much is what DCGs are about. You may find yourself needing to do something like needing to insert some regular Prolog code. So if you put something in curly braces, it treats it as normal Prolog code. For example, rather than doing this S as a separate thing, let's take the let's get a singular noun, and then we will try to and then we'll try to do a atomic concatenation on it. So this instead could be noun plural is a plural noun could be. All right, I'm going to remove this, and I'm going to leave it there for educational value for a moment. Is some single atom, which we're going to cook up. And then we need some ordinary Prolog in order to cook that up. Okay? So what we're going to do is do phrase, noun, singular, and we're going to get an atom that is singular. Okay? It's making sense to people? And then I'm going to do atom concat and singular and S, and that's X. Okay? And X isn't a great variable name. We'll call that a noun. All right? And now we don't want this one. This time I'll try and remember to compile. And English X. And let's see if we can get some plural noun. We get cats, mouses, cats, and mice. Cats was in here already explicitly, so that's why we get a second one. But we get mouses. Yeah. So yeah, that's how you get things out. Notice this trick. I knew how many things, in this case one, I wanted to stick in the list, and so I just had a list with a variable in it, and then I could use that inside the Prolog. Does that make sense to people? What's people's baffleometer? Let's do some baffleometry at this point. And I'm gonna wait hear from people's baffleometry. And people are typing. Several people are typing. Okay, cool. Couldn't come up with that on my own, but it makes sense. Repeat what the curly braces do. Okay, I will repeat what the curly braces do. The curly braces move you from DCG land back into ordinary Prolog body. So we're still in Prolog, and come in and this thing is a noun, is a plural noun if it is some element called noun, and then we're going to do some ordinary Prolog that itself has to succeed. If it fails to succeed, then this isn't a match, and we back up. Patrick, are the comma separated values in the DC boundary? Yes, they are. They correspond to subsequent elements in the list. Let's add one more plural noun here. I'm going to noun, plural, noun. Let's make it singular. I can write Empire State Building. That would be one way of doing this, but another way would be just to make them separate items. OK. A Empire State Building scares a Empire State Building. A Empire State Building scares a cat, and so on. So honestly, they are fairly straightforward. I want to show you what gets generated, just because sometimes it can be fiddle with the guts. For example, let's look and see what sentence actually does. And these things just generate arity 2, or if they have an argument themselves, like sentence here. This is going to be a arity 2 plus the number of contextual arguments. This thing's called a contextual argument. So that's going to be arity 3 in this case. And out what gets generated by using listing. Oh my, okay, there it is. And it's going to do something kind of interesting. It adds 2 arguments. If you remember from watching the Sparrows and video, Marcus's video, this you will recognize behavior that we get with a difference list. So, noun phrase, and the difference between A and C must be a noun phrase, and then the difference between C and B must be a noun phrase. Okay? So, these things are just difference lists that are under the surface. In fact, this is a pattern you will encounter sometimes in just kind of day-to-day programming. I make a thing. Prolog can feel a little plodding at sometimes. I make a thing and then turn it into another thing, and then I into something else, and then I turn that into something else. And you will find Prolog programmers encounter that situation. We'll just kind of out of the blue use a DCG. I find myself that doing those kinds of tricks oftentimes sort of adds to the mental load of whoever's read, so I don't recommend it. But okay, is that as most of DCGs? Somebody asked, why is there an underscore in noun? Yeah, I think we got that one. Other questions? I don't understand that last bit about using this in the conversions. Pilm, I'm down here. I'm going to make up a little thing. Foo gets converted from X to Y. Is expected to be used, X in and Y out. And we have to call bar to get X to A, and then blah to convert A to B, and then Baz to convert B to Y finally. Okay, so we've got that, and that's okay, but it's a little wordy and hard to read. And we can actually write the same thing, crazily enough, as bar, blah, Baz. And some people it's cleaner. I tried seeing the answers to sentence singular A, B on my are the way they are. SB, yes, they are the way they are because they are. I'm going to demo it for people. Okay, I'm going to say sentence singular A, B. Okay. This is going to be a difference list. So A is going to be the stuff. A Empire State Building scares, a Emperor State Building, and then whatever's in B, because that's a difference list. So if I come back here and I say and I put the empty list in, I then get normal solutions. So yeah, I'm warning you all off of using normal things. I guess I'm warning you in case you encounter it. I think even now, if I encounter, I would kind of know the trick, but otherwise, that's pretty opaque to me. The admonition, don't be clever when programming, actually does apply to Prolog. It's just the bar for what constitutes clever is a bit higher. But I would put this in gratuitously clever programming. Okay. Do people want me to, let me see if this compiles. I believe so. Is bar, blah, and Baz aren't defined. Okay, and so I will toss this in the student folder. Here. Okay. Okay, so I'll put that in the student folder. It'll take me just a moment, but I'll do it right away here. And And otherwise, I thank you and see you back on Slack. And I think we're out. Keep asking questions, but I'm going to end the stream.